So the exercise says that Charlie likes both apples and bananas. He consumes nothing else. And the consumption bundle where Charlie consumes XA apples per year and XB bananas per year is written as the notation for point coordinates, where the first number is the number of apples, the second is the number of bananas. So I already know that my horizontal axis I have apples because it's the first number here. And my vertical axis has bananas because it's my second coordinate here. His utility function is given by XA times XB. So that's a very simple utility function. We just multiply both of the goods. So question A, if Charlie consumes 20 apples and 5 bananas, what is the utility? What is the level of happiness? Well, let's substitute. X equals 5, and that is equal to 100. So that's his level of happiness, 100. What if he consumes the bundle 10, 15 instead? Well, in that case, 10 times 15 equals 150. Notice that I'm calculating using this formula, just this simple multiplication, just because this is the function. Different functions, I'll calculate the level of utility according to the function. In the slides, the example was XA plus XB. That's why I was adding them there, but here the function says we are multiplying. So on the graph below, plot several points that lie on the indifference curve that passes through the point 25. Well, there's the easy way to do that and there's the hard way to do that. Let's start with the hard way. Well, what do I know? Is that the indifference curve passes through the point 25. This point is here. If the points lie in the same indifference curve, what do I know about these points? I know that they give me the same level of happiness. That's why they are called indifference curve. Every point in this curve yields the same level of happiness or the same level of utility. If they yield the same level of utility, that means that when I substitute in my original function here in this example, they must give me the same number as this bundle. Well, this number yields utility 100. I already calculate that. So I'm looking for other bundles that yield 100 when I substitute here. Well, this is a simple multiplication. So I'm looking for bundles that when I multiply XA by XB, I have 100 as the result. Well, let's see. 50 times 2 is 100. So I can try the bundle 50 apples, 2 bananas. Notice that I'm trying and verifying here. Well, that works because 2 times 50 is 100. So let's put here 52. Well, I can go the other way around. 2 apples and 50 bananas, because I also know that 2 times 50 is again 100. But in this case, my point is here. I have 20 and 5. I can also try 5, 20. 5 times 20 is also 100. And I already had suggested the point 25, so let's repeat it here. But the point is already there. Anyway, I have enough points. Let's draw the curve. And that is my indifference curve. Now, that was the hard way of doing things. Now let's see the easier way. Recall exercise of graphology last chapter. Obtain the equations of the indifference curve that passes through the following points, 25, which is this curve here that we just draw. So I have the curve. Now the purpose is to find the equation. How am I going to do that? Well, let me repeat the utility function here. Now let's recall the exercise of graphology. How many variables do I have here? I have 3 of them, U, XA, and XB. Can I graph 3 variables in 2 dimensions? The answer is no. What do I have to do to graph them? Well, I have to pick 2 variables to graph, In this case, I already picked xb here and xa here. And what do I have to do with the other variables that I didn't choose to graph? I have to keep them constant. Which makes sense, because this is called an indifference curve. My u, which is the third variable, will have to remain constant. That's the only way you can graph two variables in two dimensions. The third variable, in this case, u has to remain constant. The constant equals to what? Well, if the indifference curve passes through the point 285, I already know my level of utility. It is 100. Every point in that curve I am indifference to, therefore it yields the same level of utility. Thus, I'm going to have the following. 100 equals xa times xb. Now, it is very convenient to solve the equation for the variable in the vertical axis. Remember, in high school, we always had y equals f of x, whatever the function was. We solve for the vertical variable. That's going to make it easier to take derivatives later on. So let's start getting used to that by solving for the vertical variable again. That would be xb. So xb equals 100 divided by xa. And that is the equation of my first curve. Let's do the equation that passes through the point 10, 15. Similarly, u equals xa times xb. I have three variables. I am graphing xa as xb. U has to remain constant. Constant equals to what? Well, if the curve passes through the point 10 apples, 15 bananas, every bundle, every point in that curve must yield the same level of utility. What is the level of utility of 10, 15? Is 150. So 150 is going to be constant. I have to keep it constant because I can only draw two variables. Equals xa, xb. Again, always solve for the vertical variable. In this case, xb. That yields xb equals 150 divided by xa. Now we're supposed to draw the curve that passes through the point 10, 15. Instead of guessing and verifying like I did previously, that's why I called it the hard way, now that I have the equation, all I have to do is use the equation. For instance, if xa equals 2, xb is going to be 150 divided by 2, that's 75. If xa equals 3, xb is going to be 50. If xa equals 5, 150 divided by 5, that's 30. If xa equals 10, that's going to be 15. Supposed to be above here. If xa equals 50, xb is going to be equals 3. So this is not exactly well drawn. The curve is here. Again, I'm not the best drawer. There's a better draw in the key of this exercise. Now let's go back to graphology. Remember, this is my original equation. I have to choose my two variables to draw, xa and xb. The third variable has to remain constant. When I change the variables I chose to graph, I move along the curve. U was fixed to 100. If I change xa and xb, I was moving along the blue curve. If I change the variable I did not choose to graph, the variable that was supposed to remain constant, if I change it, that shifts the curve. So it shifted from here to here. The reason is always the same. Change the variables I chose to graph, meaning the axis, move along the curve, change the third variable, you're always going to shift the curve. Now consider this. Charlie has 40 apples and 5 bananas. Donna offers to give Charlie 15 bananas if he'll give her 25 apples. Would Charlie trade? Well, let's see. His original utility is, again, the same example, so it's the same utility function. So it is U equals 40 times 5, which is equal to 200. If he doesn't trade, he will continue with the same level of utility. Now, what is the utility if he does choose to trade? Well, he's gonna end up with how many apples? He had 40 initially, but if he does trade, he gives 25 away. So it's 40 minus 25. And how many bananas? Well, he started with 5, but he's going to get 15 from Charlie. So that's going to be 5 plus 15. That multiplication is actually equals to 300. 300 is larger than 200, so he is happier. So is he going to trade? And the answer is yes. Okay, question 8. What is the larger number of apples that Donna could demand from Charlie in return for 15 bananas? Okay, so let's see. U is going to be how many apples? Well, he starts with 40, but he's gonna give a number of apples that I don't know what, so he's gonna end up with 40 minus X apples. This X is what I'm trying to figure out. It is the number of apples that he is gonna give when he trades. And how many bananas? Well, he's gonna get 15 bananas. So he starts with 5 plus 15. Okay. To convince him to trade, or at least be indifferent, he has to achieve at least the same level of utility that he had before, which is 200. Now, solve this equation here for x. I have x equals 30. That is, Charlie is willing to trade at most 30 apples for 15 bananas.